Hi everyone, and welcome to Versent AI webinar series. My name is Jaden Kerr, a senior software engineer here at Versent, and I'll be your host for the next 10 weeks. So, who are we? Versent is a leading Australian consultancy specializing in data and AI along cloud, digital, and identity. We're known for our deep technical craft, outcome-focused delivery, and our partnerships with both AWS and Microsoft. With over 1,000 people across Australia, we work with some of the country's most recognized brands and government agencies to architect, build, and run modern technology solutions. We're thrilled to have you join us as we explore the ever-evolving world of AI. In this series, we'll dive into what's possible today, what's coming next, and how to navigate it responsibly. Each session will dive into real-world use cases, practical frameworks, and expert insights to help you move forward with confidence. Today's session is designed to help you cut through all of the noise and focus on what matters most, enabling your organization to adopt AI in ways that are secure, ethical, and impactful. Here's this week's speaker, Raul.
Hey Jaden, thanks for that. I'll take over from here if that's all right. Can everybody see my screen? Can I get a thumbs up maybe? Cool. I assume everyone can see it. Cool, thanks everybody. Pretty excited to be talking to you today about all things agents, autonomy, and AI governance. So before I go ahead, a bit about me. I'm a senior data and AI engineer at Versent. My background is in stats, data science, and data engineering. A bit about my experience. In the past, I've done a lot of work around data, ML, and MLOps, mostly on the Databricks and AWS ecosystems. In the last couple of years, though, I've shifted a lot of my work towards Gen AI engineering. So, for example, building RAG systems, MLOps pipelines, as well as areas such as AI governance and AI assurance. Some other areas that I'm also very interested in include AI ethics, data governance, and responsible AI. So here's a rough agenda for the talk. Just to give you some context, to be honest, this talk was entirely motivated by my frustration with the overuse of the word AI agent, how it's been thrown around everywhere, although many software engineers and still some AI practitioners don't have a full grasp of the term. So I decided I would go down a rabbit hole to really unpack the term and find the substance within AI agents. This led me to the concept of autonomy and AI governance, both of which I had worked with in previous gigs. Now, without a doubt, AI agents have capabilities that are certainly unprecedented. I don't have to tell you that. You've played with the latest agentic tools and workflows. So my intent with this talk is not to sell you AI agents, but instead to share the latest research insights around agents, autonomy, and AI governance, and show you how all of these are interconnected. I hope that the message that you take across today is that good AI governance practices are and will be one of the biggest challenges to bring and keep healthy AI systems in production. But before we go any deeper into AI governance and autonomy, let's start with a question that we're all wondering about. What really is an AI agent? When I started looking more deeply into agents, I found more than 10 definitions of the term AI agent out there, many of which contradict each other. I think most of us by now are familiar with the AI agent workflow. As you can see, the diagram in the slide, where a user prompts a foundation model. Around that foundation model, there'll be a scaffolding orchestration layer whereby the model can interact with an environment. So for example, an API, then the model gets a response, which is downstream fed back to the user. So we know what an AI agent does, but what exactly makes it an agent? So for example, would you consider a traditional RAG an AI agent? If not, what about a graph RAG? Is it only an agent if it interacts with an API? I think the answer to a lot of these questions is quite blurry. So instead of getting caught up in semantical definitions of AI agents, it's a lot more productive to talk about the degree of agenticness of an AI system. And what I mean with that is that we can measure the main characteristics of these systems, As you can see on the slides, mainly four, which I will go through. First one, goal and execution complexity. This relates to how complex the task at hand is, whether the task has to be divided into smaller tasks and subtasks, how much planning the system has to do in advance, aka the planning horizon, as well as the depth of reasoning for each of these tasks and subtasks. Second, environment and goals. This corresponds to the different areas that the agent can interact in and the ability to also interact with external tools, as we've seen. The next one is robustness. This relates to how well the AI system can adapt to changing circumstances in its environment. So, for example, if an agentic coding assistant gets an error while doing a build, is it able to find a workaround or not? And last but not least, autonomy, which is the ability of the system to carry its intended goal with minimal human oversight. Now, once we have these characteristics, it's a lot clearer to understand why AI agents are so unprecedented, mainly because they perform so well across all these four characteristics. To put it into context, if we compare an agentic coding assistant today with an earlier LLM-powered chatbot, you would agree with me that the agentic coding assistant would outperform the LLM-powered chatbot in all of these characteristics. Now, in this talk, as I've mentioned, we'll be diving deeper into autonomy, as I hope to convince you it's the most important characteristic for AI governance. Now, before I move on, let me clarify some semantics, because I think it's a lot more productive to think in terms of the degree of agenticness of an AI system, as I've shown you on the slide. I'll tend to stick to the term agentic AI system instead of AI agent. But in the context of this talk, I might use the two terms interchangeably. Also, I should mention that the focus of this talk will mostly be around AI agents and not agentic AI, which is the next paradigm shift in frontier AI where you have multiple agent collaboration. However, with this agenticness way of thinking, you can think of multi-agent systems as just agentic AI systems that have a higher degree of agenticness. And therefore, all the lessons that we'll learn today will apply to the architecture as well. So let's start with the question, how is autonomy relevant to AI governance? As the team from Hugging Face very eloquently put it, the more autonomous a system, the more we cede human control. Now, this is extremely important to understand because any governance is about effective oversight and guardrails, whereas autonomy is about ceding control. So you can see how these two would naturally be at odds. But if you still don't believe me, the Governance Institute of Australia and the National AI Centre released a white paper last year where they flagged this as a concern. Quoting from the white paper, as AI systems become increasingly autonomous and complex, the potential for unintended consequences and ethical dilemmas grows. So to summarize, the higher the autonomy, the higher the risk. We are already seeing examples of this, where, for instance, agentic coding assistants have deleted production databases. Now, this will keep happening for more autonomous systems with heavier consequences, and perhaps more implicitly where we don't realize so obviously. So how can we mitigate these risks associated with autonomy? This is exactly where AI governance comes into play. If you're unfamiliar with the field, AI governance is about providing those frameworks and guidelines to mitigate the risk of AI system development across the AI ML lifecycle, which is the diagram that you can see on the slide. Essentially, it tells you how to bring an AI system from zero to production and provide it business value. Now I should mention that AI governance is not only about providing those best practices and frameworks on the monitoring on the blue box that you can see, but across all the steps of the lifecycle. So, for example, effective data processing will require effective data governance. And an effective model development and deployment will require something like a proper model registry where you can version control and tag your AI models. Now, to fully understand the challenge at hand, I would like you to imagine the following scenario, which, by the way, is based on a real story. Imagine you're a mid to large organization with a few dozen AI systems in prod and are facing the following challenges. First, you have some data and concept drift in some AI systems. Two, you don't have a centralized data and ML practice across the organization and also the lifecycle. Next, you have agentic AI systems in development with higher degree of autonomy, while having a backlog of drifted AI systems that you would like to review and improve. So the dilemma is, how do you systematically know which agentic AI systems have a higher risk profile, and therefore you should prioritize accordingly? Most of us, if you come from data, you will be very familiar with the notion of a data swamp, and with a rapidly evolving landscape of agentic AI systems, this will be a very fitting analogy where we'll see many AI swamps across many organizations. So how do we solve this challenge of governance and prioritization to avoid an AI swamp? To even start addressing that challenge, let me flip the question on the slide's title. And instead of asking, how is autonomy relevant to AI governance? Let's ask, how is AI governance relevant to autonomy? I think here's where we can learn a lot of lessons from data architecture and data governance, where taxonomy will always be crucial for any effective governance. And what I mean by taxonomy in the context of autonomy is measuring the autonomy of agentic AI systems against a standardized reference point, will gives us a measure of the risk profile of an agentic AI system, which in turn we can use to prioritize governance. So for example, by measuring the level of autonomy, we can tag our models in our model registry accordingly and prioritize that backlog. Or even by measuring the level of autonomy, we can restrict the testing environment based on the level of autonomy. Now, autonomy will of course not be the full picture of the risk profile of agentic AI systems, but it's certainly a great start. So producing a framework to measure the autonomy of AI systems is exactly what the ISO 22989 set out to do in 2022, which for many of us will seem like a lifetime ago with the current AI product release cycle. So this framework, which you can see on the slide, identified 7 different levels of autonomy and a description associated with each level. So you can see level 0 no automation up to level 6 highly autonomous system. Now, this was a great stepping stone, but it's unclear to me as an engineer how actionable this is. For example, I would struggle to place some agentic coding assistants or agentic workflows today between, say, levels 4 and 5 or 3 and 4. So the question is, can we draw insights from other industries to iterate on this taxonomy and improve it? And the answer is absolutely yes, if we consider self-driving vehicles. This is exactly what the people at Interface set out to do with the collaboration of the Ada Lovelace Institute, who do a lot of work and research around AI safety. They produced an autonomy framework earlier this year that is heavily inspired by the UK Automated Vehicle Act, which was passed in 2024. Now, the main benefit of this framework is that it showcases more agentic scenarios and provides more details by identifying the role of different personas. So for example, a developer, user, and an agent. Now, I won't be going through every single box of the framework on this slide, but I'll give you an overview by going through the 5 different levels of autonomy that they identified. Starting from level 1, reactive AI, this would correspond to systems that only take users' input, but there's no orchestration whatsoever. You can think of this as a standalone LLM, an early ChatGPT, or even a classic machine learning model. Level 2 would be goal-oriented AI. Here, the system has some orchestration, but it's not driven by the system itself. So again, here you can think of an ML model or a standalone LLM, and then you yourself build the orchestration layer via, for example, a Lambda function or an Azure function. Level 3, we've got adaptive AI. This would be so-called tool calling agents, where the system is able to interact with external tools. For example, agentic workflows via NAN, which you probably heard about. The next is level 4, semi-autonomous AI. Here, the system has a longer planning horizon and is able to tackle more complex tasks. So, for example, Claude Code, Gemini CLI, even deep research might start scratching the surface. Level 5, self-directed AI. This would be the next paradigm shift, where a lot of the control is ceded to the system itself. AutoGPT, or more likely a future release of AutoGPT, would be a candidate for this level. Now, this autonomy framework is very well motivated, based on very well established research, and quite frankly, on an industry that has had to wrestle with the idea of autonomy for a lot longer than the AI community has had to. However, I should mention that this framework was written more from a policy and legislation angle, so it has some limitations for the AI engineering community. Mainly, I think the high ceiling for highly autonomous systems is not high enough. It doesn't account for multi-agent systems, at least explicitly, but most importantly, we are already starting to scratch the surface of levels 4 and 5. So I don't think it will be predictive enough for 2026 and 2027. Now, other organizations have produced more actionable frameworks that will be closer to engineers' works and probably hearts. I'll go through Hugging Face's one, as you can see on the slide, since it has a lot of overlap with the previous one. Very similar to the previous one, they identified 5 different levels of autonomy. And the really neat thing about this diagram is that they also included some very, very high level code of what would be the logic of the agent for each level. So going through the 5 different levels, level 1, processor. Similar to the previous framework, here the AI system is purely a tool, such as standalone LLM or a classic machine learning model. Level 2, a router. This might be a more sophisticated chain where the AI system decides when to run its logic. Here's where some orchestration and agenticness starts to emerge, and therefore the risk profile increases accordingly. Level 3 would be tool-called agents, very similar to the previous framework, where a system can interact with external tools, for example, MCP. Now, even if developers limit what tools the system can access, the system can still decide when to use what function and what parameters to pass to that function. This is what I would expect from most AI agents today, and it's where AI governance starts being absolutely crucial. Level 4, multi-step agent. Here the system has a longer planning horizon, where solving more complex tasks requires planning and dividing the work into subtasks. Therefore, the system has control of how long the task will take to complete, i.e. the runtime, and therefore interruption mechanisms are crucial. I would argue again here, this is where Claude Code, Gemini CLI, AutoGPT are starting to fall into. And then the last level, level 5, fully autonomous agent. In this case, the human has ceded complete control to the agentic system, potentially as well the infrastructure needed to run that system as well. This might be a next generation agentic AI systems with not only multiple agents, but also a hierarchical structure of how those agents collaborate with each other. Again, very hard to predict, but I would expect here that the system's goal is very open-ended and the runtime of the task a lot longer, potentially weeks and months. I think the best we can hope at this stage is that there will be some sort of emergency stop button. And also at this level is where a lot of the AI safety research is taking place. So to me, as an engineer and AI governance enthusiast, this framework gets a lot closer to something more actionable. However, I should add the lens of this framework is still very much at that research point of view. This one in particular, as I mentioned, was released by Hugging Face a few months ago by a paper, LangChain release, and another very similar one on a blog post a few months ago. So still very much at that research stage. So here's my collective challenge to our AI community. Can we iterate on this research and start turning it into a fully fledged and adopted taxonomy? I think this is where we need to look up to data governance examples such as Data Mesh and Data Vault, which have shown that this can be done. You can develop and produce a methodology that, although might evolve over time, people and organizations really take on board. All right, so I'm aware that was a lot of information to digest. So I'll start wrapping up by summarizing some of the challenges and opportunities ahead. First challenge, context. As pointed out by this quote from a paper, what is considered autonomous depends on the environment and constraints. Unfortunately, as we've seen with the example of self-driving vehicles, we can't simply copy and paste an autonomy framework that works in one area and then paste it onto another area. The concept of autonomy varies depending on the domain, which will make it very difficult to establish a domain-wide framework for autonomy in agentic AI systems. Second challenge, using user in charge. In the context of agentic AI systems, I don't think we still have a very clear notion of who's in control and when, as these boundaries will be quite blurry. Now, compare it to the case of self-driving vehicles. While not perfect, there are more established control protocols where you can draw a line of who's in control and when. So, for example, if the human gives up control of the steering wheel or the brakes, you might say the vehicle is the user in charge and the human becomes something like a supervisor. The next challenge, rapid industry evolution. Our industry has become the fastest growing industry. I think we all have felt it and are struggling to keep up with all the new tools, which will make it very hard for AI governance to establish frameworks that can keep up with the product release cycle. The next challenge, policy and legislation. And like for the case of the Self-Driving Vehicle Act, there's no extensive legislation for agentic AI systems today, covering key areas such as accountability and liability. Now, this is crucial because it is very likely that some agentic AI systems will be considered employees of organizations in the next year or two. But currently, there's no legislation for these systems covering areas such as accountability and liability, which will be crucial when these systems keep making unintended mistakes. Next challenge, certifications and standards. Now, apart from very few outliers, the AI community doesn't really enforce standard certifications like ISOs. This is why I put yet within brackets, because I think it opens the door to a wonderful opportunity for us to learn from other communities, such as cyber, where certifications and standards have been around for many, many years. This is a good segue for the opportunities ahead. First opportunity, responsible AI. Now, you can call me optimistic here, but as part of my work, I get to work with a very wide range of clients, and I still haven't come across a single client who doesn't want to develop and deploy AI systems responsible. Now, if you are wondering what responsible AI means, that has a very specific ISO meaning, which spans areas such as ethics, transparency, privacy, accountability, etc. I think this gives us AI engineers and leaders a great opportunity to leverage and really lead the way by showing what responsible AI development looks like. The next opportunity, recycling governance patterns. As I've mentioned throughout the talk, AI governance shares a lot of similarities with data governance, and therefore there's no reason why we shouldn't implement some of the lessons learned in that field. For example, one of the lowest hanging fruits would be rigorous lineage and logging of decisions in agentic AI systems. Now, advancements in frontier AI, such as chain of thought, might facilitate this, but it's still very early days. Next, continuous research development. Although, as we saw, this rapidly evolving field presents challenges to AI governance, it is also a thriving research area that is making a lot of progress. Every month, there are new methods coming up to measure the level of autonomy in agentic AI systems. For example, I came across this paper by GitHub, Microsoft, and a few other unis that was proposing a method, code inspection method, to measure the level of autonomy, which would improve scalability. This will allow us engineers to leverage AI governance not in a slow and bureaucratic way, but from the bottom up, where the development of these systems happens anyways. The next opportunity is the benefits of AI governance. Now, I've shown you today multiple autonomy frameworks today, and although they might have some limitations, it's clear that these frameworks allow us to move from vague marketing notions of AI agents to much more detailed, measurable, and actionable criteria that we can feed into governance mechanisms. So, for example, as I mentioned, tagging your model based on the level of autonomy so you can prioritize your backlog accordingly, or even restricting the testing environment based on the level of autonomy. I think this is more relevant than ever because across all frameworks I've shown you today, we are already developing intermediately to highly autonomous systems. And last opportunity, developing human-centered systems. Now, this last point is crucial. As many organizations have pointed out, these highly autonomous systems we are already developing might make mistakes that would lead to heavy consequences. I think this presents a wonderful opportunity for us to implement human-in-the-loop mechanisms when architecting these agentic AI systems. I think by having a human in the loop, you are already implementing some default governance and autonomy oversight into the system. but also from a systems design perspective. Through my work, I have experienced how much more valuable it is to develop AI systems that empower people in your organization instead of replacing them. So that wraps it up. Before I leave, I have a question that has been bothering me since preparing for this talk and reading more about self-driving vehicles. So I hope it will bother you too and spark some thought. So in the context of agentic coding assistance and workflows, at what point does the driver become the passenger? I'm going to let that sink in. So I hope you enjoy the talk. Here are the references. I'm not sure if we have time for Q&A, but please, if you have any questions or thoughts, feel free to reach out the Versent team, and I'll be more than happy to follow up.
Thank you so much, Raul, for that incredible presentation, and thanks to you for joining today's session. Before we close, I want to highlight how Versent can support your AI journey beyond this webinar series. We offer a Pathfinder for AI Governance, a free, tailored workshop designed to help you assess your organization's AI maturity and define a clear roadmap for ethical and secure AI adoption. It's built on a proven framework used by one of Australia's largest public-facing companies, and it covers everything from strategic deployment and policy alignment to continuous improvement and monitoring. You will walk away with a benchmark of your current AI maturity, ideation on high-value AI use cases, recommendations for policies and guardrails, and a roadmap to accelerate enablement and reduce risk. If you're interested, you can reach out to us at ai@versent.com.au to book your workshop. If you have any questions or follow-ups about today's topic, you can reach Raul at the email at the bottom of the screen. So what's next in this series? We still have 9 weeks to go. Next week, week 2, the 21st of August, our speaker Raj, a senior principal in digital, has his talk, How Microsoft Customers Are Using Copilot to Solve Real-World Problems. In other upcoming sessions, we'll be diving into topics like AI-powered customer experience, Gen AI use cases in healthcare and operations, and how to build secure, scalable AI systems. So keep an eye out on your inbox for an invite to these. Thanks again for being part of Versent's AI webinar series. We look forward to helping you unlock the full potential of AI safely, ethically, and with impact. I hope you have a great day, and we will see you next time.